I guess we're back. Streaming, trying day 10 on the same day. It's getting to be a speed run this. Well, not speed really, but you know. Alright, so we're trying day 10. Let's see here. I had some questions apparently. But so my dyslexia always kind of hits me when we get these kind of long, verbose puzzles. I kind of just want to get down to the gist. Like, what is it that I want to do, or gonna do, or supposed to do? I don't want to read the story. But so there's some. It's a battery is dead somehow. You'll need to plug it in. There's only one problem. Charging outlets near your seat produces the wrong number of jolts, whatever that is. Combination of volt and joule, I guess. Always prepared, you make a list of all the voltage adapters in your bag. Each of your voltage adapters is rated to a specific outlet voltage, your puzzle input. So that is the rating on my adapters, I guess. Any given adapter can take an input 1, 2, or 3 jolts lower. Oh, okay. So 1, 2, or 3 lower than what it is rated for, and still produce its rated output voltage. In addition, your devices have built-in voltage adapter rated for 3 voltage higher than the highest rated adapter in your bag. In addition, your device has a built-in voltage adapter rated for 3 volts higher than the highest adapter in your bag. If the adapter lists were 3, 9, and 6, your device built-in adapter would be rated at 12. Okay, so max plus 3. Treat the charging outlet near your seat as having an effective voltage rating for 0. Since you have some time to kill, you might as well test all your adapters. You wouldn't want to get your resort and realize you haven't even charged your device. Get to your resort. Okay. If you use every adapter in your bag at once, what is the distribution voltage difference between the charging outlets, the adapters, and your device? For example, suppose that you have in your bag adapters with the following voltage rating. So we have a few of these. 19 and 3. With these adapters, your device built-in voltage adapters would be rated for 19 plus 3, which is 22 volts. That's what we were discussing prior to this. Because adapters can only be connected to a source 1 to 3 voltage lower than its rating, in order to use every adapter, you need to choose them like this. The charging outlet has an effective rating of 0 voltage, so the only adapters you could connect to it directly would need to have a voltage rating of 1, 2, or 3 of these. Only one you have is in a adapter rated of these. Okay. Only one you have is an adapter rated 1 jolt, difference of 1. From your 1 jolt rated adapter, the only choice is your 4 jolt rated adapter, difference of 3 from your 4 jolt adapter. The adapters 5, 6, and 7 are valid choices. However, in order to not skip any adapters, you need to pick the adapter rated 5, difference of 1. Similarly, the next choice would be 6, then the adapter 7, and so on. The only adapters that work with the 7 jolt rating adapter is the one rated 10 jolts for difference. From 10, the choice are 11 or 12. Choose 11, difference of 1. After 12, the only valid adapter is 15, difference of 3, then 16, difference of 1, then 19, difference of 3. Finally, your device built-in adapter is always 3 higher. So its rating is 22 jolts, always a difference of 3. In this example, when using every adapter, there are 7 difference of 1 jolt and 5 differences of 3 jolts. Have I only moved with 3 and 1? 1, 2, 3, 4. I missed 1. Okay. So here's a larger example. This larger example. Use all the adapters. There are 22 differences in jolts of 1 and 10 differences in jolts of 3. A chain that uses all the adapters to connect the charging outlet to your device built-in adapter and count the joltage difference between the charging outlets and the adapters and your device. What is the number of 1 jolt differences multiplied by the number of 3 jolt differences? So I guess the result from there are 7 differences is 1 of 5 differences of 3. Was there 5 threes? 1, 2, 3, 4, 5. Well, no, okay, 1, 2, 3, 4, 5. No. One, 2, 3, 4, 5. Okay. So I guess the result of this would be 5 times 7 would be the resulting from this portion. I'm not sure. It feels like a quite verbose text. For what we're trying to accomplish. Okay, let's start with this. No, let's start with this one. And write something. Okay, let's stir be equal to this stuff. And we'll pipe this into our stir splits. And we'll pipe that into our map int of string. And this is supposed to give us something, a list of sort. Okay, so it seems like, I mean, either you can use the adapter or you can't use the adapter. We always start at 0 as I interpret things. And so we have to be able to use that one. So, I mean, what we want to do is just, or to begin with, is sort this, I guess. Sort. We don't want to sort it uniquely. I assume you can plug it into the next one as well. Pervasive compare. So this would create a sorted list. So from here we have our starting point. What we want to record is the steps that we have to take. So I mean, it's really just the difference between each. But let's break them into a set of 3. So this we'll pass into a list.fold. Fold left. We'll take our accumulator and our elements. We'll do something. We'll start off with something here, a type. Diffs. And we'll add, right, so this is a type. So we'll add a at, which is an 8. We'll add a list zeros, list which is a list of stuff. Okay, so we have our at 1s, 2s, 3s, and 0s. We'll just make one, which we'll call diff. Oh, we have to add some commas here as well. People are still with me, that's nice. Nice to get some support. So our starting point was 0. Zeros, 1s, 2s, 3s, and that's it. We have to add some of these, kind of missing shards for everyone, I guess. So into our fold we want to pass our empty. So let at be equal to act.at. So that's that one. And now we have our element, which is from the move we want to make from at to our next element. And seeing that we had this, just move the closest one in order. We can't move. We can only move in one direction, so we always have to move in one. Yeah, in one direction basically. So okay. So if e minus at, let's do this. Switch e minus at, so e will always be greater or equal to at. So if this is 0, then we'll return accumulator. Actually, let's do this. No. Accumulator at is at. No, at is e because we moved one step. And zeros and zeros with the list of, well, it doesn't really matter. We could just have counters, but let's add the elements as well. So this was a 0 move. Right, we have to assign it to 0 as well. Zeros. And this is ac.0. Okay. 1. So that is once. Twos. 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 Threes. And we have to deal with default case even if we're sure that our input is gonna support it. So let's just return accumulator there. Okay, so for this input we now we'll assign this to the results. So what was how did we compute the results? What is the number of 1 jolt differences multiplied the number of 3 jolts differences? So that would be then js.log 2 length of res dot once list length of threes and we're supposed to multiply this. Errors. Oh, yeah. So we were actually declaring a list here, not assigning the type. There we go. Seems to be compiling since it's out of format, but no. Twos. Taus. So we get 28, which doesn't seem right. Or did it seem? No, I think we have to add another 3, right? Since our charging device was what 3 had a difference of 3 from, yeah. So we have to add one more. But more to the point, this was 5 times 7. 5 times 7, which is 35. Okay, yeah, that's kind of tired. Okay, so 35 is what we're looking for. We are at 28 at the moment. We have 3s. Oh. This has always bugged me. Like, why use quit to exit? Why doesn't exit work? Alright, so 3 and 7 and 4. Yeah, so from this we also have to find our largest number in... So, okay, let's divide this into... be equal to that stuff. So we also have to find our max. So max is equal to input, and we had our max of lists, so that would be our max, and we'll now have to add this res equal to res 3s equal to list.append res.3s lists. I think there's actually an easier notation for appending lists. I think it was the at sign in prior versions to the current version in Reason. I'm not sure if it works anymore, but probably should try. So anyway, we're supposed to add max dot plus 3 because that was our device. So now this should yield us 35, which it does. Hooray! I kind of want to try if there is a simpler way to just append lists, because you keep doing it and list.append is cumbersome. Nope. It doesn't work. See, ReasonML changed to ReScript, or they rebranded to ReScript, and then kind of redid a whole bunch of things. So I'm kind of curious, or they redid a whole lot of the syntax, which made some things more complicated. So I think migrating from upgrading your code base, I wonder if they address the at sign here somewhere. Nope. No, they don't. Okay, let's see. Lists and arrays. Did they give us any clues? Oh, right. Can I do that twice? I wonder if I can. This is not the 0, and that is. So I mean, this is just tail and head. I want to concatenate 2 lists. I mean, that one is actually kind of what I'm trying to do here, since I'm only appending one item. So in this case, this is actually quite what we're looking for. It's still mad at me. Why? Wasn't this supposed to be working? Or does it only work with the head? That's useless. I want to do it with the tail. Or add to the tail, rather. Why would they only allow for the rest and not... Well, I mean, it's not useless. In this case, it doesn't really matter in which order, but seeing that we appended things backwards, I mean, we could just kind of try to convert these. So it would be something like this. And then we'll move this portion. So this works, yeah. So I mean, this cleans up the syntax slightly. It's still not too... I don't like that it's not generic. I mean, you would assume that this would work either way and not just specifically for one. Oh well, okay. So let's try this with the real deal. Data to stir. So that gives us 2664. Does this yield us the answer we've been looking for? That does yield us the answer. Oh, how nice, and how confusing part 2 seems. Who? Okay. To completely determine whether you have enough adapters, you'll need to figure out how many different ways they can be arranged. Every arrangement needs to connect the charging outlet to your device. The previous rule about the adapter can successfully connect still applies. The previous rules about when the adapters can successfully connect still applies. The first example above, the one that started with 10, 16, 10, 15. Yeah, so that's that one. Supports the following arrangements. Yeah, so everywhere to basically get from 0 to 22 would be acceptable. The charging outlet and your device built-in adapter are shown in the number in the parentheses. Given the adapters from the first example, the total number of arrangements that can be connected to charge your outlet device is 8. 1, 2, 3, 4, 7, 8. Okay. The second example started with many. Here's the arrangement. Okay, so in total, this set of adapters can connect the charging outlet to your devices in 8 ways. Here are a few. Okay. Distinct way. At a glance back at your bag, you try to remember why you brought so many adapters. There must be more than 1 trillion valid ways to arrange them, surely. There must be an efficient way to count the arrangements. What is the total number of distinct ways you can arrange the adapters to connect your device? It seems that we have... Okay, so we have to, for one, figure out all the different connections. Okay, so we have to figure out all the different connections and then count the distinct ways of accomplishing them. So we have one, so this is the base case where you connect all the different adapters, and then there's obviously some shorter arrangements. What is the total number of distinct ways you can arrange the adapters? I wonder if there's any duplicates in the data. Does it bring like multiple 40s? Does that exist? I'm just gonna curious how to reason about this. So input length js.log sort unique yeah, so there's 108 different adapters. That might help us. So then we don't have to deal with duplicates, because I mean you could have duplicate adapters arranged and, you know, have them switch places and be pretty much the same deal. So I figured this is kind of like in a graph. We have a 0, and then like what are the valid connections to a 0? So that would be 1. Well, that's only 1. And then like what is the valid connection to 1? That's only 4. But then we get into the interesting part. So that's like a node, and then like a 0 and a 1 and a 4 that is connected somehow, and then they split into 3 different branches, 5, 6, and 7. And then you have to do that again for every. The question is, can we end up with duplicate, like if we count each path, or when we end up at the bottom, we would probably have like each, that is a path. So if we end up at 22 or at 19 in this case, it doesn't really matter. Does each path would represent one distinct option, and there could there be one more? I'm not sure. Oh, thank you. I got wine for my sambo. Yeah, so I think that might be a good way to approach this in general. I'm thinking of like trying to not like on demand draw the graph, and have some sort of recursive function that figures out like what way. Oh damn it, I spilled. Hang on, I'll be back. There we go. Yeah, so I guess my idea at the moment anyways would be to try to draw this graph and traverse it in some sort of recursive manner, and then try to figure out basically just each time it terminates or get to max, we call that, because we only have one max and we have to get to that one because our adapter is one more. So when we get there, that counts as 1. So I think that is a pretty good start. So let's see where that takes us. Exciting. Okay, so let's switch back to, yeah, we did switch. Did we? No, we didn't. Okay. Let's move this one up. No. So let's switch back to our basic nice thingy here, and we're supposed to get 8. 8 is the number we're looking for in the distinct number paths that we can take. So what we want to do, or at least what I think we want to do, is that we want to take our input and we'll pipe that into list.fold left, and we'll take our accumulator. Not sure what this will be at the moment. Well, will we? No, I don't think we should do this. We'll create a function which is supposed to be a recursive one. We will call it trace. We'll take an input. So that's our input, and we want to trace all the subgraphs, right? So we want to in this input we want to trace all the subgraphs basically. So we'll see where it goes. We'll do something like this. Maybe there is some fancy math about this that we could figure out, but I'm not sure. So the base case here in our recursive function would be that if input is in is a keyword, damn it. Okay, never mind. Let's keep it to input. So if list.length is equal to 0, there is no more because we have traversed it to where we want to go. Then we'll return 1. No, I mean, this could be quite an exponential growth. So we want to do this tail recursively, right? So this means that we will need an accumulator, which will just be a number. So we'll return accumulator plus 1. Does this... Wait, I have to look at some old code. State. I change the state and return it. Well, maybe we can't make this tail recursive. Okay, never mind. We'll just call that a 1 for now. Else we want to figure out what to do. So if there is only one option, so I mean there is like 3 options here. So the first one is that we can only reach the next item has +3, so that means there is no branch. We must go there, but we definitely know that like the next 3 is what is possible, or the next 4. No, since zeros can be terminated here, right? We didn't need our zeros, as we figured out, since there was no duplicates. So we can remove the idea of a 0 here. Does this still work? No, okay, it's winding over there, so that's fine. So we need to look at the first 3. So it kind of becomes a nested if statement, which is ugly. So I'm not sure I want to do that, but bear with me. So, okay. If well, no. Okay, so if nth list of nth, so input, and we'll grab our third element. Does the nth grab our third element? Yeah, or is it? It's 0 index, right? Yeah, okay. So if that one is equal to, so we need to have our current here. So if nth is equal to current plus 3, that means that we will have at least 3 elements that we could branch over. So in that case, we'll call trace. So we'll return trace. So we'll return trace input. What is current? Right. So we'll return the nth, the first one in the list, and the rest of this, the input to the next iteration, that would be everything but the first one. So in this case, let's use our awk take, no, drop one from input. And to this, we'll add the first element, and we'll drop 2. And we'll add the third element, and we'll drop 3. So this would be this one. And if the second input is equal to current plus 2, that would mean just this portion. And, well, I mean, this would be else, but, so let's make this slightly. So that would mean taking the first element and dropping 1. Yeah, okay. So now we have our trace. So let's try this. So this should give us something. So input, we'll pipe into trace. Well, people at work trying to holler at me. Okay, so where were we? Yeah, right. So trace, and what we want to do is list head of input, and list dot tail of input. So this should recurse and give us a number, hopefully. Yeah. No, where am I going? Okay, so I have some. Oh, right. I removed the 0 just to mess things up. That one has to be removed. Was there anything else? Failure nth. Is it one indexed? Seems strange. Returns the nth element, the first element, the head of the list as its position 0. Raise failure nth if the list is too short. What did it raise? Oh. Shoot. Seems like we should. I mean, so the problem here is basically that we are at the end of the list. And so I guess we could do and length input. Do this. Well, that one doesn't matter. And here, len is greater than 2. Len is greater than 1. Oh, shoot. Did I add? Where did I add the? Oh. Forgot the. Did you forget? Did I? Not sure. Oh. So that gives us 1. Why does it give us 1? Doesn't it get here? No, it doesn't seem like it. Zero, 1. What is the problem here? 10, 9, 8. So what is current? Oh, right. I probably have to sort this. Input list dot sort. Okay, so now we got our 8, which was what we were looking for. How nice. Okay, so this should then, if we have thought about this correctly, this should give us the answer. Maybe we should try it prior to running the real code. Just try this slightly larger example, which was supposed to yield us 19,208 paths. Oh. But it doesn't. Wasn't supposed to yield us, the first one was supposed to yield us 8? Where am I going wrong? Am I going wrong? So in the first example, they have a path that yields you 3 branches as 3. And then we have 6 that branches to 1, 7 that branches to 1, 10 that branches to 2. 2, 3, 4, 5, 6, 7, 8. What happens if I run this with the real data? So it's slow. It doesn't resolve. That's 100 lines. It seems like I actually managed to do this tail recursively. Otherwise I feel it might have. So here's my trace. No, it's not actually tail recursive. So my computer is burning up. But, I wonder if it makes any difference if I add. So for example, if we move back to this one, why didn't we get this one? It was supposed to yield 19,000 distinct paths. And we have our max here, so I wonder if we should just append list dot does that yield anything different? No, that's still, I mean, yeah, it shouldn't really make any difference. Why would this be yielding me different results? So that gives me 8, which is what we want here. Here. $49 is the largest one. I mean, so there's two types of problems here that that I see. Is this the... Is this where I counted wrong somehow? It seems that it might have been... Or is it? No, I'm just trying in blindly here. Yeah, so 2 was correct here and 1 is correct here. I wonder if there's something about the assumption. I mean, so there's two different problems here. There's one problem that the recursive function doesn't seem to terminate when I run it on the long running process, and the second one is that it doesn't seem to be correct at the moment. So this will just yield us, yeah, a duplicate. Hmm. 0 plus input nth. So the current one, so that's the first. And if we'll get wait, here it is. So if the input of 3 is less or equal to, this is the problem. Now I get a too big number. Did I change something else? Ah, okay, wait. So no, since they are unique, if I've ordered them, if I'm at 1, for the third to be valid, it must be 4, which is 1 plus. Ah, okay. So I think where I'm going wrong here. I think I figured it out, but I'm not sure. It's kind of interesting. So I think the problem here is that we're adding max and not 0. So we're starting off from the first element, which might be, there might be multiple elements early in the graph, which shard off. Yes, okay. So now my algorithm is correct. But that probably won't solve anything. Seeing that if I change this to date, I assume data. I assume this will be running for quite a while. Fun fact, divide and conquer this shit. It is divided and conquered. Or it's divided, but it's not really conquered. So I mean, it is definitely divided in the sense that it's recursive, but it's definitely not conquered. I mean, each trace handles a subgraph and basically counts everything upwards from there. But I feel that there would be a pattern here. So if A you can split the list into sub-list, I assume it's supposed to be, that do not need to pass the recursion and multiply the results. Yeah, so that is actually what I was thinking about. I'm not sure where I'm going with it at the moment, but if A leads to B and A leads to C and A leads to D, I would have to so we do branch here, but the trees. No, Linus is active in the channel. Okay, so what he's saying is that we could array of an array. But I'm not sure where you're getting the numbers. So the second subset does not contain everything from the first array. I'm not sure what you're getting at, Linus. I'm not sure if it's the wine or if I'm just too stupid to figure this out, but well, I should probably terminate the program. My computer is burning up. Yeah, so instead of adding, so the problem here is that every trace leads to 1 and is subtracted on the way back. And that's if the search space is large enough, that doesn't really work too well, I assume. So let's move back to our string example. So I mean, 19,000 paths is easily executed. It's when it becomes large that's more of a problem. And damn it, I'm hot. I need to take my sweater off. Okay, so the idea here is that this trace is something that we have to follow, or my idea rather. But when we get here, so the thing is that this one, the third, that will be a subset of this one. And this one will be a subset of this one, right? And so if we just look at this one, where we have this thingy, so I guess this would be like twice this plus 1. And thrice this plus 1. No. So the idea here is that, like, we have one path that we're following. We're following this one to B and so on. And so this one doesn't really have anything else. So we just return whatever the sum is of that subpath. Well, my idea is that, for example, looking at 2, we have A leads to B. And A also leads to C. No. But here, B also leads to C. And whatever C leads to. So we don't have to do the wait, what did I do? So I guess I have to add 2 there, right? And 1 here. No, that's still too small of a number. It seems like it should be correct, but I'm probably missing something. So if A leads to B and A leads to C, C must be 1. So I guess B also could lead. No. A plus 1 plus 1 leads to A plus 2. A plus 2. There needs to be some math going on here. Feels like I'm just trying things out here. See what happens. It seems like there should be like some sort of relationship in terms of this, but I'm not. Yeah, that became a large number. No, we overflow, but that's not what we're supposed to do. Okay, so I'm cheating here, getting help from the channel. So the idea here, which I kind of feel that it might be. What am I doing? I have too long of a buffer here. So the idea is that my original thingy was quite fine. The question is like, how does this? Yeah, so this yields me the correct result. So the idea is from the channel, or from Linus in particular, that we probably could run this on subsets of our, simply that we could partition our graph or our input and then multiply them together, and that would somehow yield the correct results. I'm not negative to the. Oops. I'm just not. I kind of feel that it might be the way to do it. I don't know. Haven't worked too much with graphs that I know the math of it, but I think we have some sort of partition thingy here. So this returns a partition. How do I even partition it? I mean, would that work with just 2 elements as well? I probably would have to have 3 in order to figure out, or 4. So let's go with 4 if that turns out to be append. Okay, so I would have to do some sort of. Did I sort the input already? Okay, so here I sort it. I add 0 to the list. I'm not sure or was that the what? That was the original problem, right? Yeah, that was the original problem. Okay. So, what do we do? What do we do? What do we do? left. Do we have a fold left eye? That's the one we don't have, right? It's always kind of annoying. We have a map eye. Yeah, we don't have a fold eye. Gosh darn. Okay, so here we have some code. We need to partition our thingy. So we'll add an accumulator. Type parts. Okay, Linus, is there a... Oh, okay. All right, type. And we need a L, which is a list of int 64.t, and we'll need I, which is an int. Cool. Partition. I'll add a list as L. Okay, so there's different help going on, conflicting. I'm not sure if there are conflicting views, but no, there's no zip width in Reason. But okay, you guys are on the same page. So okay, so I think I kind of got it. So the idea is that we multiply every time we get a difference of 3 between the current element and the next element. So that's when we partition. So that actually probably makes things easier. In a sense, we don't need that much of our partitioning thingy. We probably only need, well, we need a list of our current working list, I guess. So our list, and we need our I, which would be our last. So let's call that last element. and our current, let's call it part. Okay, so the accumulator then would fold over. So we'll get each input in turn, and then we'll see if we get an in turn. Okay, so yeah, I think we're on our way, as the song from Collins goes, I guess. All right, so we'll start with part of a list and the last of a 0. So if this turns out to be E, right, so we have to do the whole int compare. If E, let's see here, if E and last, if E is greater than 0, last plus 3, then we partition. So here do partition and stuff. Else, if that is not the case, then the only thing we really want to do is continue this thingy, but we want to add to our list, we want to add E and our current list, which would be our accumulator dot part, and we'll replace last with E, so this would be integer dot 0, and now we don't need this 0 over here, so let's call this input 2, input 2, input 2. And just do this stuff. Okay, so seeing that we add this 0 here, it should be fine. Okay, so otherwise we just add to the partition. So now no, we don't have sit by. I'm pretty sure this is what we got. Sorry, it's from the comments. You could probably write most of these functions. I know there are some in belt, but so belt is an extension of the core library. It's not really the core, but kind of the core, as I understand things. So things in the list API is not. Yeah, exactly. So belt versus standard. So belt has more or less become what most people use, as I understand things, when it comes to reason, to accept some extension to the core library. But I kind of try to use the core library only in this case, since it is, I don't know. I haven't just used it, I guess. Anyway, I think I've written a sit by function pretty soon, or solved it or something. So, okay, now we have, we compared it, so this is where we want to split our thingy. And, right, so we actually want to have the result here. Res. Probably. Yes. Which is an int64. .t, and result also turns into 0. There we go. Okay, so what we want to do here is, now that we found that last.3, that E is currently larger than this one. So what we want to do now is actually just perform. So res equal to accumulator.res. Well, let's just do the trace thing. And the current here so we want to do this thing with our part. Compare. So we're grabbing our parts. We want to send in the head of the part, and we want to send in the tail of the part. So this becomes our intermediate results. So we probably want to change this to 1. No. Yes, a 1. So the idea now, now we have the results, and the idea now is to change the accumulator, I guess. Here we just add to the list and add last E. So we kind of want to do the same thing here. Part now becomes an empty. No, it becomes E. List of E. And seeing that we didn't use E in our we just found out that okay, we need I. So our last where did we use last? Last becomes so this might as well be 0, seeing that we want to add more than 1 or 2 elements before we do this operation. And results becomes accumulator.results times res. Okay, I have no idea if this works. This obviously doesn't compile. All right, so where's the problem? We missing a dot. There are some missing commas. Last, right, we can just add this. It's int 63, 64, dot add. Int 64 dot of int, maybe. last. Oh, it's supposed to be accumulator. This is an int. How is that an int? Oh, because I specified it to be. Well, am I mixing up things now? This could obviously be an int. That's not the issue. Let's go back. But I need to compare with E. What is E? So E is the input. Oh, right. I'm mixing this up with the last exercise. Oh, gosh darn it. Ah. So this might as well just be ints. I'm tired now. So if I well, if this equals this, then we'll do the whole splitty-do. Int 64, 0, 1. More int 64s. 0. Else. What is wrong there? The second field is undefined in res. Oh, right. So we have to... Right. There we go. So what do we get out of this? And we want to print res. So this isn't correct. I still have... So here, 1, 2, 3, 4. Plus 28. So let's do this with the more simple example at first. Can we get this to work with the most simple one? Do we want to use input 2 here maybe? So that gives us 8. It did give us 8 in the prior one as well, though. So this is one path, and from 1 to 4, this gives us 4 paths, so 4 to 2, 3, 7. Okay, so why doesn't this thing then give us the correct answer? So this gives us something completely different. 0, 1, 2, 1, 2, 3, 4, 1. Can I make this as like an arbitrary place? So okay. So the idea, I guess, is that we want to, instead of, we want to multiply by our branching factor. So a segment that only so if we have a partition that we know only have one branch out, we multiply all those together and multiply all the remaining ones together. It seems that that should work. This one has been going on for too long. I wonder if it is... Should I include... I mean, I'm kind of in the blind here. I wonder if I should include E here. What happens then? Wasn't that the syntax? Was it like that? No. Oh. What if I do like that? No, then things become smaller. So maybe I should do like a -10 here. I'm kind of going off my Twitch comments here. That, but it seems reasonable. The idea being that all the subgraphs should multiply What happens if I do... Does this change the result? Yeah, it does. So maybe I have to add max plus 3. Did that change anything? Nope. Since there is only one terminating path. Wait, here's something sketchy going on. 1, 2, 3, 52. How did that get added? Oh, right. Oh! Was that that? Damn it. So it was the terminating ones that was the problem. Ah, right. Because there might be a path. So there has to be a path. Okay, so that was a problem. Alright, I see. So now does this actually do what it's supposed to? I feel that this wasn't all I hoped for. Gosh darn it. So it's a big int. So we need to make it int. Oh, so one of my friends from way back when, he has a masochistic... Where is this Sato? Which one is the one that's the one to inflict pain on the other? It seems like he has one of those feelings, or he likes to see me in pain. Yeah, so I'm definitely in pain at the moment, but I think we're kind of drawing to end here. So res, this would be my int 64.1. And where do we use res? Here we use res. These will hopefully not be too big, these traces, so I hopefully could just do one of these bad boys of int. We log res, and in our accumulator we int 64.mul. We multiply these together. We do get a large number. So let's pipe this into int64.toString. Is this our number? A ridiculous big number. Oh, finally, I can walk my dog. I have to walk my dog now. Gold star. I see why this works. If wouldn't had the support of the channel and did the stream, I would probably been googling around somewhat for finding out the math. It kind of makes sense to me. Not too intuitive, I would say, but looking at it, it definitely does make sense. Like if you see things as a cluster and you only have one path out of that cluster to the next one rather than an actual graph, clustering things on the same level in the graph, or in the tree rather, that grows. So yeah, we'll see how things. Apparently I'm still in the lead in our local Advent of Code leaderboard. Can I view the... Yeah, so here we have our other friends. Now I outed them. Sorry. And apparently how you can join as well. Probably not the best idea. Cool. So this was quite a long one. Two Advents of Code in a row, and one that definitely it's kind of a bad thing that you start off with the easy ones, and the hardest one is what you do after like 2 hours into it. But yeah, so I'm gonna commit this to my repository and probably clean it up tomorrow because I'm too tired to do it now. Nice for the ones to join. This one obviously took me 2 hours. Slightly embarrassing, I feel. But yeah, I feel this has potential to be quite small and nice if I just clean it up somewhat. All right, cool. Thanks for the support, Johan and Linus. Shout out. It wasn't too clear instructions to begin with, but I figured it out from your instructions, so that's definitely helped me out. Google is also nice, but it kind of isn't that fun to watch on a Twitch stream, I assume. You'd rather see me suffer, so I'm here to please, I guess. All right, guys. I guess I hopefully see you guys tomorrow, Friday. I hope it's a good one. Cool. All right. Good night to you all.